Science Alliance. I am Lara. This is Theory of Science. I stream free live lessons just into internet. I do. That's literally my full-time job now. It's basically busking. That is what it is. I teach free live lessons, and if people like them, I'll show you at the end how you can support me with £5 a month. That's good, isn't it? Like, I've got a science degree, first class, drama degree. I'm trained to teach physics to A level, and we're going to learn about astronomy together. Come on! Right, let's do it, because the activities, it's not complicated, is it? Could you please stick a piece of A4 paper to some sort of like cereal box? You just need to make a screen, right? We're going to make a rainbow. I invented this activity on my first ever lesson 6 years ago. I'm really proud of it, and I just cram it in wherever I can, basically. So if you're new, this is the classic Theory of Science activity. Make a screen by sticking a bit of paper to a cereal box, and we'll make a rainbow while I chat to you. So you wanted me to teach you about astronomy. Someone said, can you link it to the IGCSE physics spec? Like, if you do a big posh exam in astronomy, it'd be quite good if we'd already learned some stuff with you. So I'm like, yeah, it's a great idea. So I had a look at what you need to know. And some of the things, the word waves just kept coming up. So I thought, okay, we'll do a lesson about waves to start with, so that all the other stuff we learn about space, we're like, oh yeah, I know what that means. So while you're sticking paper to a cereal box, I'm going to do the thing that I always do. Regulars have seen me do this so many times. I don't care. It blows my mind every time, right? Have you ever thought about if you get two magnets and you hold them near each other, you feel a push or a pull, even when the magnets aren't touching each other? So I've got really strong magnets here. So I'm getting them that far away from each other, and they're really pushing back. And if I turn one around, I can feel a really strong pull, even though they're not touching. What is that? What is that, chums? How do they know? I mean, they don't have brains, but how does the magnet detect that the other magnet is there when there's space there? What is it? Is there a particle passing between? Well, what it is magnets are surrounded by invisible force fields. Invisible force fields all around the magnet, and that's what the other magnet is detecting, okay? And at this point, I usually just move on. But I was doing loads of extra research on the internet, like I do, and I found a really great explanation of actually what a field is. I usually just go, yeah, magnetic field around the magnet, so the other magnet can detect it, and like little pins and needles and stuff can get into the magnetic field, and then that's how they know the magnet's there. What actually is a field? So this person, Tricycle Road Rage, just did this brilliant explanation on Reddit, and I'm not going to repeat that, but basically what I'm saying now was all their idea. You know, you've probably stuck the paper to the box, haven't you? What you need to do is get a wine glass of water, or if you haven't got a wine glass of water, get a normal glass of water and a food can, and that's been working quite well as well. So a wine glass of water and a food can, or a normal glass of water, and just put it in front of the box like it's a screen, okay? So, you know, when you watch the weather, I don't know if people do this anymore, when you watch the weather on TV, the person will have a map with maybe some temperatures on it. So I live in the UK, so it's a picture of the UK, and it'll be like, oh, the temperature in London today is 25 degrees, and in York it's -12. So that's kind of like a field of temperatures. It's an area of space with different temperatures. And then the next slide they might show you might be the wind. So that will have different wind speeds, 20 degrees, like 2 miles per hour, 5 miles per hour. But there'll also be a direction, right? An arrow showing you which direction the wind is traveling in. And that's kind of like a field as well, like a wind field. So a magnetic field is like that. It's an area of space where things experience a force, like things are pulled in a certain direction. So if you've ever put a needle next to a pin, a needle next to a magnet, you'll know that it starts to move in a certain direction, right? Because it's in the magnetic field. So fields in physics are like 3D areas of space where you put certain things in them and they experience a force. And where's my favourite bit of, here we go, my favourite bit of plastic. It's not just magnetic fields. We've also got these things called electric fields. We don't need to go into this too much. But basically there are particles that are positive and particles that are negative, like charged particles. You will know this even if you don't know this, if you've ever rubbed a balloon or a plastic bag on your head. It's the same sort of thing, right? I've made the bag and my hair negative and positive. I know we could do a whole separate lesson on this, but you can see like my hair is being attracted to the plastic bag now without actually touching it. So around stuff that is positive and negative, you've got an electric field, which is just the same. It's an electric field, and if you put a charged particle in an electric field, then it experiences a force. So scientists worked out, it was Faraday who worked out that magnetic fields and electric fields can come together to make electromagnetic fields. And that is what we're in right now. The whole of the universe has an electromagnetic field. This is a lot, isn't it? This is just a lot straight away. If you're watching live, it's like 9:10 in the morning. The whole universe, you are sitting right now in a massive 3D electromagnetic field. Magnetic field, electric field, working together. And if this were not enough, if you've got a glass of water in front of you, you can do this now for learning reasons. When you makes water vibrate, you see ripples of energy, right? It makes waves. You can tap water. Let's do it right now, chums, because you learn better with your hands or something. If you tap water, you make waves, right? We've got this area of space, water, and we make vibrations in the water, and you can see the edges of the water, even though they're not near my finger, they're moving because I'm making the water wobble, aren't I? Waves of energy are traveling from my finger to the edge of the glass. You know what I'm going to say, don't you? Yeah. You can make the magnetic field, the electromagnetic field that is all around us, wobble as well. Here's a picture of what scientists imagine that it looks like. Magnetic field, electric field at right angles to each other. And this is a wave in the electromagnetic field, a wobble, if you like. And like everything, I feel like I'm giving you so much information. So we're in an electromagnetic field, right? And if you wobble the electromagnetic field, it makes waves of energy travel through the electromagnetic field. And just like you could tap your finger very sort of slowly into the water and make a kind of long, leisurely wave, or you could tap it really fast and make a wave that's got loads of energy. It's the same with the electromagnetic field. So some things vibrate the electromagnetic field loads, and you get waves that are very close together with loads of energy. And some things vibrate it in a very leisurely way, and you get these extremely long waves which carry less energy. Now, it's all just a wobble in the electromagnetic fields, right? But for ease, humans love to categorise stuff, don't they? So humans have sort of split these waves up and given them 7 different names. Like we've named the really high energy ones something, the low energy waves one thing, and all the ones in between something. But they're all the same. They're all travelling at the same speed, and they're all just wobbles in the electromagnetic field. If you already know all this, because some of you watch my IGCSE physics lessons, and we've done all this in a lot of detail. If you are one of my IGCSE physics students and you're like, yeah, Lara, come on. All right. Can you please, if you've been to my website and you've got the free printout, you've got it in front of you, I've made it all easy for you. If not, you'll have to sketch it. If you know all this already, can you label all these electromagnetic waves, please? And can you tell me which ones of these waves are around you right now? And also, if you really know your stuff, because a lot of my IGCSE physicists, if you're going to do IGCSE physics, you definitely need to just know the names of all these waves. Can you tell me why? Which of these electromagnetic waves are around you right now in your room, and why? Question mark. Because English skills. There. For the rest of you, you do know the names of a lot of these little categories of waves that humans have made up. One of these waves you have evolved probably to detect it with your face, or certainly humans in general can detect one of these waves with their faces. We're making a rainbow, aren't we? Which is a massive spoiler for this question. Should we just make a rainbow? I'll tell you. Light, isn't it? How is physics? I mean, what just happens to be that waves that are this length, that are carrying this amount of energy, humans just evolved for those waves to be able to travel into our eyes and click something off in our brains that make us see. I know. Let's make a rainbow because we've finally got to light, okay? Right, I need to go and steal my husband's mobile phone torch. What you need to have set up is your screen with a wine glass of water in the front. If you haven't got a wine glass of water, then like I say, I was very pleased that someone told me they didn't have a wine glass of water because it made me think of this and it works fine. You need a can. Other kidney beans are available with just a normal glass of water on it like that. It kind of makes a glass, right? Right, I'm really sorry. I just have to abandon you now to get my husband's mobile phone because he hasn't delivered it right into my hands. Like, what is that? Right, I'm actually here. I was just shouting, he hasn't delivered it into my hat. Oh, open the door and he's standing right there. Amazing. Okay, I'll flip you back around. All right, so I'm so sorry. If you're watching this on a mobile phone, then this is dead awkward for you, isn't it? You'll have to wait until later. But what you need to do, and it's really weird, it took me ages to work this out, I won't blind you. Turn a mobile phone torch on, and then you put the mobile phone face down on the table, so the screen's facing the table like that, so the light's shining upwards. And then, I can't tell you how long it took me to work this out. What you do is, for extra cool effects, you have to slowly push the mobile phone torch towards the wine glass and see what happens. If you haven't got a mobile phone torch and you're having to use another torch, it is a bit awkward, right? I suppose what you could do is maybe put all this on the edge of a table and move the torch facing upwards towards it like that. But it is better if the torch is facing upwards. Okay, so I'm going to slowly move this towards the glass. Gasp. What's going to happen? Oh. I don't care if you've done this with me before. It's so good. I love it. It's still my favourite activity. Can you see what's happening? We get a rainbow. Okay, I'm going to keep pushing the torch towards the glass, but I'll zoom in here so that you can see the rainbow happening. Oh, so beautiful. Oh, come on now. Oh, the world. Oh, what an amazing place it is. So I've sort of made a double rainbow there. I'll pull it back down again like that. Hopefully you can more or less see all the different colours. Shall I try it with a not wine glass, with our homemade wine glass? TM Theatre of Science. Here we go. See if it works for you guys. So I'm just pushing that towards that. Oh yeah. Oh my goodness, what is going on here? Whoa, upside down. Oh my days. This is even better. Cool. Okay, I might keep that one actually. That's awesome. So you're obviously seeing this through a phone. Hopefully if you're doing it at home, you can see a few more colours than I've got on the screen here. Right, we better move on, hadn't we? We better move on because we're supposed to be talking about astronomy. So I said to bring a candle and something to light it with if you wanted to. You really didn't have to do that. I wanted to bring it just to sort of demonstrate, make science real. Because everything, there's so much to say, there's so much to learn. So we've talked about how you can wobble the electromagnetic field that is all around us. Magnetic fields, electric fields working together. We're sitting the whole universe is in a massive electromagnetic field. You put certain things in it, it experiences a force. You can wobble this electromagnetic field and waves of energy travel through the universe and like through your house and your body right now. How do you make those waves? Well, it's just like when you dipped your finger in the water. It's things vibrating the electromagnetic field. And everything vibrates. Everything in the universe is vibrating. Some stuff is vibrating a lot, like the air particles around you are moving around a lot. Some stuff's just vibrating a little bit, like the things, solid objects tend to vibrate less. But everything is vibrating. And the hotter something is, the more it vibrates, right? The hotter something is, the more energy it gives off. I feel like saying it loads of different ways is actually making it more confusing. But basically, everything in the whole universe is wobbling the electromagnetic field. Some things are only giving off. I need to tell you the names of the other waves. So we have evolved to see light. but there are loads of different types of waves. Waves that are, oh yeah, so, beg your pardon. What I wanted to say when we looked at the rainbow as well was that what we did there is we got white light and we split it into all the colours of the rainbow. So you probably knew that already, but if you didn't, when we see light, which is white, it's actually all the different colours of the rainbow mixed together. And that's not even, that's like colours are something that really only happen in our brain. So what is happening is, it's not just that our brain is seeing waves with this much energy and going, oh, I'll call that light. Like obviously this bit of light over here has got less energy, and this bit of light over here has got more energy. So our brain sees light with exactly that amount of energy, and that amount of energy on that wave travels into our brain, and your brain goes, I'll call that red. And then if it's got this amount of energy, a little bit more, if the wave is slightly shorter, that travels into our eye, and our brain goes, oh, let's just say that that's purple. It's so weird. Like nature doesn't really the universe doesn't know about colours. The universe is just producing these waves, and it's our human brains that are going, yeah, all right, I'll say that's red. I'll show you yellow when we get that one. That one's blue. That'll definitely help you to survive on the earth and tell what is what. So yeah, that's giving you a massive clue, because wavelengths that are slightly longer than red, we can't see them with our eyes, but they are definitely there, and stuff is giving them off, and we call them infrared. Ah, yeah, right. And on the other side, what do you reckon? Red, orange, yellow, green, blue, indigo, violet. What do you call a wave that is slightly shorter than violet light? So we can't see it, but it is there. It's just that our eyes haven't evolved to see it. It's ultraviolet, exactly. Should we get rid of these? So slightly higher energy than ultraviolet. You get X-rays. You probably know that X-rays are quite dangerous. If you have an X-ray, the people who are doing it will sort of leave the room in between, because you can't be exposed to too many X-rays. The wave that's got even more energy than X-rays we call gamma rays. Definitely don't get into a room with those guys. And then the ones that have less energy than infrared are microwaves. And then right at the end we've got the really long chilled out ones, radio waves. So there's radio waves travelling through your body right now. You can't even tell, no problem. Right, so our brains have evolved to see light, but there's all these different waves that exist, and the only real difference between them, apart from how much energy they've got, is that we just haven't evolved to detect them with our faces. I mean, that's not necessarily true of infrared. So I've got a candle here. I'm going to light the candle. Don't you do it unless you've got an adult in the room with you, okay? Don't just be playing with fire for theatre science. I can't afford that kind of lawsuit. But I just had a candle that wasn't lit. Now the candle is giving off light. What is the difference? Why is the candle giving off light? I mean, we could talk about the chemistry here, but we're not going to. Why is the candle giving off light when it wasn't before? So pretty, isn't it? I've made it hotter, yeah? So everything in the universe is vibrating a bit, wobbling this electromagnetic field a bit. But the hotter the thing is, the more it is vibrating the electromagnetic field, the more energy it's giving off. So it's really weird. But this candle was giving off, like the candle wick when we could see it, it was giving off infrared. Because all the particles in the candle are vibrating a bit. All the particles in your body are vibrating, the particles in the wall are vibrating. Everything in the universe is vibrating a bit. So the particles in the candle were wobbling the electromagnetic field enough to give off infrared. But we can't see infrared. I've made it hotter, so now it's so hot, the particles in the candle are vibrating so much that it's giving off light. If I blow it out, then it's still giving off infrared. It's just that we can't see it. I don't know. It's weird. I mean, you probably knew that stuff gave off infrared light, even if you hadn't thought about it, because we use it for night vision. So it just so happens that stuff on Earth just happens to be the right temperature, have enough energy to give off infrared radiation, which is dead handy for us. So you might have seen an image like, if you've seen Jurassic Park, which is the best film ever made, you've seen this sort of thing. This is a camera that detects infrared waves, and the higher energy infrared waves, like the hotter the thing is, the brighter it is. So you can see the tyres of the car that are driving along, they've got really hot because they're moving against the road, whereas like the windscreen is much cooler. That's been shown in purple. But yeah, you know, don't you, that that's not actually what the car looked like if you saw it in real life. That's us making a piece of equipment that can detect infrared so that we can see stuff that our eyes haven't evolved to see. And that's what this whole astronomy module is about, right? Okay, so right, I'm getting close to giving you a sheet to do because I've done so much talking. You're probably used to seeing images taken using visible light. So here is a gorgeous, gorgeous picture of the moon, which is kind of what you would see if you looked at the moon through a telescope. We will talk about why it's not exactly that in a sec. So we know that light travels through Earth's atmosphere to Earth and goes into our telescopes, and we can look into the telescope and see the image, yeah? You've also got radio telescopes as well on Earth, collecting radio waves, because everything in space is giving off all kinds of different waves. So why wouldn't you want to be able to see stuff that is giving off radio waves? I've put this diagram in here. Sorry, that. I'm not going to go into it in a huge amount of detail, but radio telescopes have to be massive because radio waves are massive. They can be like a kilometre long. So these are radio waves coming in, hitting the sort of dish of the telescope, and then bouncing back and eventually meeting a detector. Humans, we're so clever, aren't we? So this is a really new thing that hasn't actually even happened yet. You have to watch the news for this. Someone came up with this brilliant idea that instead of just having one massive telescope to collect radio waves, why don't we use loads and loads of different radio telescopes and like make them act as one massive radio telescope? So sadly, this isn't a photo. This is an artist imagining what this will look like. But the Square Kilometre Array Observatory is this massive radio telescope made up of lots of little ones. Some of it's in Australia, some of it's in South Africa. It's like the headquarters are in Jodrell Bank, which is in the UK. And it's going to be amazing. It's apparently going to be 50 times more sensitive than any other radio telescope, and it's going to survey the sky more than 10,000 times faster. But you've got to watch out for it. Yeah. So we've got telescopes on Earth that detect light. You might have even looked through one to see things. We've got telescopes that detect radio waves as well. Why haven't I mentioned any other waves? Why have you never looked through a telescope and seen... sorry, my husband's phone is making noises. Why have you never looked through a telescope that's collected like microwave radiation? We're getting to the stage where you can answer some questions for me. Why don't we use the other waves to take images of stuff in space from Earth? If you've still got your rainbow in front of you, can you add a little bit of milk? This is a massive clue. Some of you will know already, but some of you won't know already. Why have we only got telescopes on Earth that detect radio waves and light waves? Okay, I'm going to stick with my not wine glass because I thought that was working really well. Get your rainbow up again. And what you have to do, I didn't make up this activity. This is a sort of classic science activity. You've got to, well, actually, no, maybe I did. If you've got to put a little drop of milk into your water and see what happens to the rainbow. I always add too much milk, like always. That is a guarantee. I have here my child's leftover cereal so that I can put in like a tiny little teaspoon of milk and try not to get carried away and not just slosh it in from the carton. But let's see if this works. It never works, just FYI. So I've got my rainbow here. I've got my little dregs of cereal milk. You can use any milk for this. You could use like oat milk or soya or whatever. I'll keep focused on the rainbow. I'm going to put in that much milk. Just a tiny amount. It's cool, isn't it? You can sort of see the milk in the rainbow. Anyway, I'm going to give it a stir and see what happens. Oh no, are you joking? Surely, even that was too much milk. Oh, too much milk should be like my catchphrase. Okay, at this point on Facebook yesterday, I started panicking, and then someone pointed out, Larry, you've got another glass right there. Why don't you just use that? So I'm going to do that. Sorry, God, it's literally just a drop of milk. This activity wasn't made for humans like me. I always get carried away. Right, let's try that again. I'm just going to put the tiniest bit of milk in and give it a stir. I've done it again. No, I haven't. Yes, it's perfect. Chums, it's worked. What's happened to that rainbow? Can you see? Can you tell? You know what I need to do? I need to add more milk. Let's do it. You see the difference there? Oh, amazing. Oh, thank you for being here, as this works better than it's ever worked before. I don't want to lead you into answers, but would you agree with me if I said that the rainbow has got more red? We've made a red bow. Yeah? Some of the other colours have been blocked by the milk. Oh, that's a great model for what we're talking about right now. Here's a diagram from NASA to explain it much better than I could. Thanks, NASA. So if you imagine that this here at the bottom, this is like Earth's surface. This is a lovely diagram from NASA showing that a lot, thank goodness, of these waves that we're talking about don't get down to Earth. I say thank goodness, it's not a coincidence, is it? So gamma rays, X-rays and ultraviolet light, most ultraviolet light, not all of it because we have to wear sunscreen to protect us from it, but gamma rays and X-rays certainly get blocked by Earth's atmosphere. Yeah, this lovely cosy blanket of air that is shrouding the Earth. It's not lucky, is it? It's not a coincidence because we just wouldn't have evolved on a planet that was being constantly bombarded by gamma and X-rays. But anyway, yeah. So here you can see, thanks to NASA, that visible light, all the colours of the rainbow, are reaching Earth. Actually, a bit of infrared as well. You do get infrared telescopes, like this kind of infrared light can reach Earth. But most infrared is blocked by gases. In fact, you might have heard about this if you've heard about global warming, like water particles and carbon dioxide particles in the atmosphere absorbing infrared. Some radio waves do get through as well, though, although very long wave radio waves are blocked. So what we talk about, if you ever hear astronomers talking about this, is we call this bit here the optical window. Optical means light that we can see, like in electromagnetic waves that we can see. So optical sort of means visible light. So the optical window is what scientists talk about when they mean the bits of light that can get through to Earth that we can see. What do you reckon they call this bit here, where the radio waves get through? It's the radio window. Yeah, there you go. So you've got the optical window and the radio window, and you can use telescopes to detect light in those ranges. But there's absolutely no point having a telescope on Earth that detects any of the other waves because they don't get to Earth. All right, I've said too much. I've said far too much. I need to give you this sheet to do, okay? Have a go at some questions because I've done so much chatting on. I need to check whether you've actually understood any of that. I was just thinking you're not quite the right height. It's because I've stuck you on my box of matches. And this is my getting you the right height box. There we go. That's better, isn't it? What pro? Fill in these gaps, please. I've put you the little diagram at the top here with all the waves on to give you little clues. The universe contains an electromagnetic what? When it vibrates, this makes electromagnetic what, which travel through space. Some are stopped by Earth's something, but something and something waves get through and can be detected by something on Earth's surface. I will eventually give you some words that are the answers, but I don't want to do that yet. I want you to get some brain exercise. And the other question is, which of these is not found on Earth? I've got 3 telescopes for you here. The Giant Meteor Wave Radio Telescope, the Chandra X-ray Telescope, and the Devastal Optical Telescope. Which of those telescopes is not found on Earth? And explain your thinking to question 2. There you go. So I'll move the PowerPoint on in a bit and give you some clues for the answers to the first one, but I won't do that yet. Right, what I'll do actually is go and get some more coffee, because why not? It's got to be some benefits of teaching in your own house. You've got the time it takes me to go and get some coffee to fill that in, and then I'll pop the answers on the board. And I'll give husband his phone. Thank you. Okay, well done. I will put all these words on now. So some of these words need to go in these gaps, and some of them don't. Waves, gamma, atmosphere, park, our eyes, light, charge, telescopes, field, sound, and radio. There you go. Some of those are not right, and some of them are right. What else do I need to say? Like and subscribe. And also, if you weren't here at the start, then I always say if you're watching live, there's no comments on YouTube, but on my Facebook page right now is a post saying, if you're watching this lesson live, you can go to my Facebook page and put a comment on that post at the top of my Facebook page. And I'll say hi to you at the end. But you don't have to. It'd be chaos if everyone did it. Some of you will just lurk, and that's totally fine. I can see the number at the top of the screen. It makes me very happy to know that you are watching. I'll go through it in a sec, because on the first Facebook lesson, lots of people got caught out by the second question, and I was really pleased with myself. And I didn't really catch anyone out in the second Facebook lesson. So we'll see how you've done. I'm hoping that only I can hear the sound of my husband blowing his nose and not you. Oh. All right, should we go through it? So if you know it, you know it, and if you don't know it, you're probably thinking, can you please just tell me the answer so that we can get on with our lives? Okay. The universe contains an electromagnetic field. When it vibrates, this makes electromagnetic waves. There they are: radio, microwave, infrared light, ultraviolet, X-ray and gamma. They're all basically the same. Those are just random words that we give to when the waves are different lengths, different amounts of wobble, which travel through space. Some are stopped by Earth's atmosphere, but light and radio waves, which you could have put in any order obviously, get through and can be detected by telescopes on Earth's surface. So if you were doing the IGCSE question, then well done if you said that gamma rays and X-rays are not around us right now, because that would be very dangerous, but all of the other ones are. Microwaves are what mobile phones use. Which of these is not found on Earth? It was the Chandra X-ray telescope. Some of you, I was really pleased that I'd found a picture of the Devastal optical telescope in Pune, I think, in India, which looks like it's on a spaceship, but it's not. It's the X-ray telescope, which isn't on Earth, because X-rays don't reach Earth's surface. So what would be the point? You've got to put a telescope like that into space to get a good picture. So I thought, I found this lovely little sort of GIF. It's just 8 different images from a film where someone's got a telescope, pointed it at the moon, taken some footage of the moon. So the moon isn't moving, and the telescope isn't moving. But watch this video. It's very interesting. Look at that. What's happening there? So what's happening is, you're looking at the moon, or the person who was looking through the telescope was looking at the moon with Earth's atmosphere being in between. So Earth's atmosphere is air particles which are all different temperatures, like swirling and moving around. So this was a really lovely example of the problem with trying to look at cool stuff in space from Earth, is that you get this wobble. In fact, when I showed you this beautiful picture of the moon taken using visible light, I don't know if you noticed, it said this is 20 images stacked together to reduce noise. So I said this isn't exactly what you would see if you look through a telescope at the moon. Noise in photography and astronomy is when basically like not enough light has reached the detector or the telescope or whatever to take the image. So photographers take like 20 different photos with different bits in focus and then stack them all together to make the whole thing beautiful in focus. But obviously the best thing to do would be to get a telescope out into space so that you could detect other different ways. So I used to get I used to get a bit cross when I first started studying physics, and I found out that you look at like beautiful images of galaxies, don't you? I was a bit cross when I found out that those images weren't just showing you visible light. Like if you were floating in a spacesuit next to that galaxy, the photo is not what you would see, because the photo is showing you X-rays and infrared and radio waves. I was like, that's cheating. I've had to change my mind on this, because obviously if you want to study cool stuff in space, why on earth would you only look at the waves that humans have evolved to detect? That makes no sense. You need to be able to detect other waves. A good example of why this is useful. Here's what Jupiter's moon Io looks like with our eyes-ish, thanks NASA. But if we use equipment that can detect infrared to look at Jupiter's moon Io, we get something like this. So neither one is wrong, but you would have definitely missed these hot spots on the moon if you just looked at visible light. Infrared tells us where which bits of the moon are really hot, and in fact it was Jupiter's moon has volcanic activity. It was the first place in the universe we discovered volcanic activity that wasn't Earth. Again, this bit of Io with human eyes versus the same bit of Io with infrared. Neither is wrong, is it? It depends what you want to study. If you want to study the geology or geography of Io, then the first image is probably more useful. If you want to study the hotspots and volcanic activity, then the second image is more useful. Here's a lovely example. So Messier 82 is a galaxy 2 million light years away in the constellation of Ursa Major. You might have heard of it. So this image that you're looking at on the screen here, that's a picture taken of it by a telescope on Earth. That's what you would have seen if you had looked through a telescope that was on Earth in the 90s of the visible light that Messier 82 is giving off. Okay, here's a picture of the same sort of light range, really, just visible light that humans can see, but from a telescope which was in space, which didn't have Earth's atmosphere in the way. So beautiful, isn't it? But obviously that's still only the light that humans can see. What if you use infrared? Then Messier 82 looks like this. Cool, beautiful. It's not. I would have got very angry about this and be like, but you can't actually see that. That's not what it looks like. No, but those are waves that it's giving off. They're just infrared waves, not light waves. Of course, the really cool thing to do is to take loads of different images that detect different waves and then stack them all together. So here's the kind of classic like screensaver image that you would get of a galaxy, and that is what has happened there. So these are X-rays recorded by the Chandra telescope, shown in blue. The infrared is being recorded by Spitzeris, and that's been shown in red. And then Hubble has come along. The Hubble we will look next week at just at telescopes and how they work. But confusingly, the greeny yellow light is what we would actually see, except we would see it as blue. Stunning, isn't it? So it's up to you which one of these you prefer, which one of these you think is like the real one or the not real one, which makes you feel better about the universe. They're all absolutely stunning, aren't they? Humans, just, sometimes we do really well, don't we? Here's another image that the Chandra X-ray telescope took. The red stuff is visible light. The red is what we would see if we could only see visible light, and the blue is all X-rays. So that's a lovely way of being able to see inside structures. This is actually like the remains of a star that exploded, but being able to see inside stuff in space is only possible with different ways. We will, like I said, we'll look more at that next week when we look at how telescopes work. Right, you lot, that is the end of all of the information that I wanted to give you. But as usual, not as usual, but when I'm doing well, I've made you a little mystery word quiz, okay? So you've got 4 questions now. They're multiple choice. You have to choose the letter that you think goes next to the right answer. And then at the end of the mystery word quiz, hopefully you will have a mystery word. If you've got all the questions right, it will be the correct mystery word. And if you haven't got them right, hopefully you've got another word that just isn't. Anyway, you ready? Let's do it. I think some of them, I've tried to make some of them quite difficult, like deceptively difficult. Which of these waves can't get through Earth's atmosphere? Is it B, radio waves can't get through Earth's atmosphere? R, X-rays can't get through Earth's atmosphere? Or S, visible light waves can't get through Earth's atmosphere? What do you reckon? You could, I mean, there's only 4 questions, so you could probably just remember the letter, or you can write it down if you want. Which of those waves cannot get through Earth's atmosphere? B, radio, R, X-ray, or S, visible light? Right, I'm going to move on. Which of these waves is not an electromagnetic wave? So these are all waves, but one of them isn't a wave that gets made when the electromagnetic field that is all around us right now wobbles. Is it A, sound, E, gamma, or I, infrared? Which of those waves is not an electromagnetic wave? Sound, A, gamma, E, or infrared, I? You got it? They're all waves, but one's a completely different type of wave. It doesn't happen by the electromagnetic field wobbling. All right, next one. Why can we see colours? Why can we see colours? Why can human beings see colours? Is it because they're very bright? Write an R. Is it because it's how our brains interpret light waves? Write an N. Is it because they're part of the electromagnetic spectrum? Write an E. Why can we see colours? They're very bright. Write an R. It's how our brains interpret light waves. Write an N. They're part of the electromagnetic spectrum. Write an E. I thought it was a bit tricky, that one. Okay, next one. I mean, obviously, I should say it doesn't matter if you don't get any of these. My child very rarely watches my lessons, but when they do, they get like 1 out of 8. So don't worry about it. Quite often, these questions are a way for me to see how well I've taught the lesson. Like when I teach it on Facebook and there's comments, if everyone's getting all the questions wrong at the end, I'm like, oh, okay, I needed to describe that a bit better. Which of these objects gives off infrared? This is really difficult. I've made this too hard. Which of these objects gives off infrared? I'm not entirely sure I taught you this. G, an unlit candle. E, a brick. T, both an unlit candle and a brick. Yeah, I'm not totally... Did I tell you? I mean, I think you'd be able to sort of guess it. But... yeah, I'm not quite sure. Maybe this is a little bit of guesswork for you. Well, no, I think I did. But I only mentioned it really quickly. I reckon you'll be deciding between two, and if you've got all the other questions right, then both the words that you've made will make sense. Oh yeah, this has worked out quite well, actually, isn't it? Oh, I'm loving how tricky and sneaky this is. Okay, are you ready for the answers? Which of these waves can't get through Earth's atmosphere? We've got radio telescopes on Earth and we've got light telescopes on Earth, but we don't have any X-ray telescopes on Earth because X-rays can't get through Earth's atmosphere. So the first letter of your mystery word is an R, a R. Which of these waves is not an electromagnetic wave? Sound is not an electromagnetic wave. It is a wave. You learn all about it if you do my waves lessons in IGCSE physics. But you can't make sound by wobbling the electromagnetic field. So we've got Ra. Why can we see colours? Well, they are part of the electromagnetic spectrum, sort of, but it's how our brains interpret light waves. So certain waves, when they travel into our eyes, send a signal to our brain, which makes our brain see colour. But actually, we see colours because of our brains. We don't see colours because they exist. It's just super weird, isn't it? And finally, so we've got RAN so far. Which of these objects gives off infrared? Well, you might have been thinking that bricks were too cold to give off infrared, but I think when I showed you that image of the car, I did say, like, everything on Earth is the right temperature to give off infrared. And obviously, like, if a candle is in your room, there's probably bricks in your room as well. And the candle and the bricks are the same temperature, right? So it was T. Candles and bricks and all the objects in your room, weirdly, are giving off infrared radiation. You just can't see it because your eyes haven't evolved that way. So the mystery word was rant. Fun word, isn't it? But if you got like rent, then well done you. Well done for just being here, frankly. All right, you lot, that is the end of the lesson. I'm going to go over to my Facebook page. and see if anyone has said hello to me. But while I'm finding my Facebook page, what I have to do is like tell you how this works, because some of you will be new and will be thinking, this is weird. What is her actual job? No, this is my job. It's so cool. So in lockdown, which you probably don't even remember, but 6 years ago, everyone got trapped in their houses and I started streaming free live lessons. And I didn't even know that home educating was a thing. And then everyone was like, oh, actually, we're still watching these. Can you keep doing them, even when lockdown finished? So I did. And now it's my job, because I just said, well, I'll set up this page. There's this website called Coffee, where people pay, like, podcasters and stuff. So there's this website called Coffee. And I say, okay, if you go to my Coffee page, it doesn't say Coffee, and support me with like £5 a month, then that'll be enough to keep these lessons going. And you do! Even though you don't have to, you do. So it's so much easier for me, because just everything's free. I don't have to have any like complicated password systems. I just stream all of my lessons for free into Facebook and YouTube. There's this lesson which you've just watched, which is like the all ages lesson. There's an IGCSE physics lesson every week, and there's something that I call the Lego story show, where I tell you a story in Lego and we chat about a thing. So this week it's on at 10:30, which is in 36 minutes. It's about the moon, because I just couldn't get the moon into the astronomy lessons, but I really wanted to tell you about the moon. So I do that as well. The lessons, not the Lego story, but the lessons have free printouts. Everything is saved on my website for watching on catch up. And I just say, if you're enjoying all this and you appreciate my work, please pay me. And you do. So I don't do any one-to-one lessons. I don't do any like private group sessions. Literally, if you are watching these lessons, you are the only students that I have. It's good, isn't it? It's really weird, but it's working. I don't know, we just sort of made it up between us. Okay. Oh, Kai's here. Rant. Yes. Well done, Kai. Hello. Oliver is 10 minutes behind, so watching this on Facebook now. Oh, you're colourblind. Want to do a Lego show or something about colourblindness? Yes, that is a good idea. I was thinking about people who were colourblind when we were doing the lesson, because I was like, colours are... like, who's to tell you that you're seeing them wrong? Do you know what I mean? Like, it's not like colours exist anyway, is it? All kinds of different animals see colour in different ways. Like, deer see orange as green, which is how tigers can be orange but be disguised in the jungle. Anyway, I'm getting super distracted. I didn't even finish with my ad. Go to the top of my Facebook page where it says sign up, or go to my about section on YouTube, or go to the comments of this video, I think. And you'll find this link to this website called Coffee, because that is the only way that I make money. So I really do need to spend time telling you about how you can pay me. It's literally the only way that anyone in my family makes money. And I will send you nice things to say thank you. I suggest you support me with like £5 or £6 a month, which sounded like more in 2020. Now, I looked it up yesterday, it's the price of like 9 McDonald's chicken nuggets. So like for 3 lessons a week for a month in term time, that's pretty good, isn't it? I was trying to find something really rubbish to compare to. Anyway, yeah, I send you Theatre of Science magazine, all my supporters, whenever it's ready, and it takes me so long. I'm so embarrassed by how long it takes me to write, because I spend ages planning the lessons. But I do write Theatre of Science magazine, and I do post nice things to my supporters every so often to say thank you so much for being my supporters. So if you sign up now, you will get some rainbow glasses that make you rainbows. You'll get a past issue of Theatre of Science magazine. You'll also get this thing which we don't usually post out, but we are at the moment, which is a little satellite model with some stuff that I wrote about how it works and what it is. You also get some more awesome glasses. It's a good time to sign up, okay, is what I'm saying. Like, there's more stuff. I just can't hold it in my hand and I don't have it. You'll get a nice package of things when you sign up. And yeah, okay, that's the end of my ad. Go, send me £5 a month. Send me 9 McDonald's chicken nuggets every month. Thank you. And that will make me continue to do my job. Okay, let's get on this, because I can see, here's this. Okay, right. I'm going to start reading my comments on Facebook now. Again, if you don't have a Facebook account, well done you. Don't feed the evil corporate machine that is also sort of almost entirely responsible for my wages. So let's have a go. Oh! Oliver's like a deer. He struggles with orange and green, depending on the shades and how much light is hitting that. That is so interesting, isn't it? Oh, Oliver, yeah, we do have to do colour blindness. I'll write it on the board. So yeah, I mean, tigers are endangered, aren't they? So it's highly unlikely that you will ever be anywhere where there is a tiger. but you would be in danger, wouldn't you? Because you wouldn't be able to see the orange of the tiger against the green leaves. Same problem that a lot of the thing that I'm going to give Oliver like horrible nightmares about tigers. Colour blindness. Okay. Yes, I've got a lot of colour blindness in my family. There we go. Hello, Sophie and Emily and Katie and Hannah. Sophie didn't learn from your mistake and added too much oat milk. Yeah, at least 2 times. Oh, but you did make a red bow in the end. Oh, that's good. Yeah, that's what it's all about, isn't it? You guys love it when I make mistakes and have to keep trying and trying again and modelling, going wrong, and things like that. Hello, Isabel. Hello, Hannah and Freya. Hannah wonders if the car in the infrared image is reversing. Oh, interesting. As there seems to be hot tracks on the road in front of the tyres. OMG, I don't know. But Hannah, now we have to go back and have a look. All right, Maud and Seffi, what are you saying? Maud and Seffi, oh wait, sorry, Maud and Seffi, your comment has been covered up by a picture of a car. Oh, I think Hannah's right. Reversing. Good spot. Wow, you make a good detective. I think you're probably right, aren't you? Yeah. That's weird. Has it seen the infrared camera and now it's, I don't know what that is. Very cool. Yeah, good spot. All right, Seffi, where's your comment? Maud and Seffi, we love your lesson. Oh, we also received the rainbow glasses and other glasses over the holidays and they are brilliant. We like the stamps too. Maud and Seffi, thanks so much for giving me a nice comment, but also like advertising my cool stuff for me. Thank you. That's really kind. Yes, we did hear your husband blowing his nose. He's got the worst nose blow ever. I've lived with him for like 16 years, so I'm used to it, but every so often it happens in public and you can see people going, what? And I'm like, oh yeah, I forgot. Anyway, I'm getting very personal. Cora, age 5? No, you are not 5. That's ridiculous. Are you still here? You can't still be here. Cora, you can't. I don't think you're allowed to learn about the electromagnetic spectrum when you're 5. You've got to forget it all. Forget it all. Don't tell the other 5-year-olds. Hello, Flynn. Hello. Hello, Aurelia. Hello. Oh, good morning. Good morning, Abbott. You like my nails? Thank you. I feel a bit weirdly self-conscious about wearing nail varnish because it's like plastic, innit? I feel like it's not very good for the environment. But sometimes I see it on the side and I go, oh, yeah. Hello, Lana and Finley. What is that? Helen, what is that? Is that a solar oven? Oh, that is the perfect activity to follow this up with. Guys, you all have to Google solar oven and then make a solar oven. And that'll be great. That's a good one. Hello, Alice. Hello, Isabel and Thomas and Lewis. All right. Hello, Jancy, which is a cool band name for Jay and Daisy and Daniel. Here's a photo of Alfred the Great, who fought the Vikings. Yes! In Wessex. His statue is in Winchester. Oh, I love Winchester. Where we visited in the Easter break. Oh, nice. There's a very cool science conference in Winchester, which very occasionally I get to. My phone camera does not do the rainbow justice, but my children are very pleased. Oh, I think that's a great rainbow, actually, being shown there. Sarah says, hi, I'm now a year older than the last time I saw you. What? That's weird. Congratulations. Hello, Bastian. Oh, no, it's not Bastian, it's Lauren. Hey, hi, Laura. Hi, Science Alliance. Glad to be back from the break. This topic is great timing with Artemis. Yes, it is, isn't it? And that is totally a coincidence. It's, well, maybe not a coincidence, but maybe that's why you lot told me that you want to learn about astronomy, because we've started exploring the moon again. Hello, Hader. Hello. Hello, Emma. It's been a long 2 weeks without you. Ah, that's nice. Hope you had a lovely spring break. Rant. Yes, correct. We went camping in the desert and used the telescope to see the moon. It was amazing and so clear. That is not a picture that you took of the moon. That's ridiculous. Wow, that's so good. Also, hello Bella, I have my showcase on Sunday. I'll tell you how it goes next week. Good, yes, good. I'm playing a girl called Fran in a duologue and we're in a sinking boat on a work trip. Amazing. That's so good. I have played a person called Fran in a play. I've forgotten about that. Yeah, I forgot about that. That's like my cool claim to fame. There's an actor called David Oakes who I went to university with. He's like, not like unfamous now. He was in Vikings and Valhalla. He played one of the English guys, so he didn't get to wear all the like cool beards and things. But anyway, yeah. he directed me in a play, and I went for one of the cool characters, and he was like, "No, you're going to be Fran. You just are Fran." And I was like, "Oh, all right. Well, I've learned some things about myself today, but I've also got a cool part to play." Anyway, Bella, sorry, that was completely irrelevant. What is that? Is that a dinosaur? Is that a really cuddly dinosaur? That is adorable. Hello, Kai. Hello, Jude and Eli and Iris. Hello, Hugo. Lyra is watching. She says, "Can you do a Lego show on Birds of Paradise? Are those the ones that do all the like really cool, weird showing off dancing to each other?" Yeah, that's going on the board. Birds of Paradise. There we go. I've put bids. I'm not entirely convinced I'll know what that says. There we go. Birds of Paradise. I wore these nails especially for this lesson. Remedy, what? Wait. Bella's getting new glasses. Very cool. My friend's got new glasses. I'm quite jealous. Everyone's wearing those hexagon glasses now. I was with 2 people and they were both wearing hexagon glasses. It's like, there's a glasses trend and I can't get on it. I wore these nails especially for this lesson. Remedy, those are awesome. Oh my days. There's nothing about that photo that I don't like. Very cool. Oh, it's Wilson. Okay, Tamara, your photo has come up differently from your comment. Wilson is a great name for a cuddly dinosaur. Hello, Fausta, who I've met in the real life. Hi. Good to not see you, but you know what I mean. Oh, and Tamara's watching with little sister Layla. What? Layla exists? Tamara, how dare you keep Layla from me all this time? Hello, Layla. And Wilson. But more importantly, Layla. No offence to Wilson. But anyway, I'll move on. It says Lila, doesn't it? Does that say Lila? I'm really sorry. I'm trying to think how I can fudge it. Lila. So that Layla doesn't know that I've got their name wrong. Oh, hi, Lila. I'm just going to move on. Hello, Imogen and Ophelia. Great to be back. We are excited for the new topic. Imogen and Ophelia. Me too. Hello, Arthur. He went to Portugal over Easter and did some stargazing. Hello, Jessica. I am also looking forward to these lessons. All right, you lot. We have really missed you over the break. Especially because we missed a few lessons. We've been looking forward to astronomy. I was in York the other day. I kept an eye out for you. You should have done. Although I went away over Easter, actually, or I probably would have seen you. I saw posters for Flamingo Land. Oh, yeah, which I did talk a lot about in my theme park lesson. Looking forward to the Lego show. Sorry this message is so long. Sorry this message is so long comes halfway through the message. From Rose and Isabella, brackets, just Rose really. Isabella is still asleep. That was sweet of you to give them a shout out anyway. Bye. P.S. Oh, this isn't for me. Hi to Jess and Amelia. I am seeing both of you later. Whoa. P.P.S. My rainbow worked really well. Awesome. I did a bit earlier. And I got everything right to fill in the gaps. P.P.P.S. When I was in York, I saw the concrete bricks that stacked like Lego bricks. Did you? They are in York. No. I need to get out more. Hello, Ezra and Oren. Oh, they're not watching. We'll be catching up later today and have been enjoying catching up with the astronomy from a few years ago. Oh, right. Yeah, okay. Yeah, I didn't say, did I? I forgot to say that on my website right now is an astronomy lesson I've already taught called Astronomy We Can See. Like, you stand in a field, you look up, you can see stars and planets, actually, and maybe comets if it's the right time. So this is about astronomy that we can't see, these lessons. All right, Toby. Oh, Toby! It was your solar oven photo that I was looking at. Facebook is putting the comments and the photos in different places. Toby made a solar oven in his science lesson on Monday and made a s'more in it, and we talked about infrared light. There you go. Everyone should go make a solar oven now. It's a great idea. Hello, Magnus. Hello, Zen. Hi, me and my son will be watching from sunny Sheffield. I live near enough Sheffield to know that might be sarcastic, but maybe not. York is pretty chilly today. Maybe Sheffield's a bit further down south, aren't you? Maybe it's nicer for you. All right, you lot. This is the bit where I say I'd better go because there's only 23 minutes until the Lego Story Show, which will be here. And we all need a screen break, frankly. But then I don't actually go. I refresh the comments to make sure that I haven't missed any. So this is that bit. I'd better go. I'm actually going to read more comments. Is he? Because I wouldn't have known that Jacob was here. So now I know Jacob's here, so that's important. I mean, I know that Jacob's here because Jacob's always here. But I don't know, he plays it cool sometimes. He doesn't say hello. He messes with my head. I'm like, is he here? Or is he not here? He's here. He knew all about this. You can get fake glasses, Lara. Oh! So I can get cool hexagonal glasses. game changer. Of course you can. You can get fake glasses. My mum gets her glasses online from Firmoo. It's a funny word. And you can order the frames. Amazing. They do mad shapes. Come on. Flynn wants to say that. So Flynn is also a year older. Flynn is now, oh, that's too old. That's intimidating amounts of old. Or if you do a colourblind lesson, you could do it about Willow and Darcy. Tetrachromacy. Tetrachromacy. I can say it. I don't know what it is. Tetrachromacy, innit? You know, tetrachromacy. I'm just going to write it down underneath colourblindness. Tetrachromacy. Fausta, what are you saying? What got created during your session while listening to every word, of course? No. What is that? What? It's... Good grief. Oh, that looks beautiful. Oh, hello, the Martins. Okay, Facebook is telling me that is all the comments. I'm very sorry if you've commented and I haven't seen your comment. Sometimes Facebook sort of buries some of the new comments. There's Cora. Cora's probably not watching anymore. Cora, go and have like a run around, right? I don't know. What do 5-year-olds do? Go and like play with Play-Doh or like put paint on the walls. Don't do that. I'm only kidding. I know you're not going to do that. Right, anyway, okay, I have to go because in 11 minutes time I'm doing a Lego story show about the moon. I need to have a hot drink and reset the Lego story, do all kinds of stuff. Go off, have some fun. I'll see some of you in 21 minutes time for a show about the moon, and I'll see some of you next week for learning all about telescopes. Don't forget to like and subscribe, but more importantly, send me actual cash money because I need those chicken nuggets. I'm not going to spend it on chicken nuggets. I'm going to spend it on like my mortgage and food for my kids. But anyway, thank you. Is it definitely on YouTube, the Lego? Oh, I've just got a Facebook message I need to reply to. Thank you for paying me. I'll see you all very soon. Bye.